Hi math students, this video is to help you with your upcoming checkpoint. So grab a piece of paper and you're going to write down these along with me, or if you want, I took a picture of this paper and attached it here so you can print it and fill it in as we go. But this is really helpful. These are examples just like the ones on your checkpoint that you're about to do, so make sure you write them down and then you can use this paper when you do your checkpoint quiz. All right, so sequences is kind of what this lesson was about. A sequence starts with 2 and multiplies the previous term by -3. Create this sequence. Okay, so the sequence starts with 2. So let's start by writing 2. And multiplies the previous term by -3. So I'm going to take 2 and multiply by -3, and I get -6. Now I'm going to take this -6 and multiply by -3 and get +18. And we just need to do a couple. So 18 times -3, I don't happen to know what 18 times 3 is, so I'm just going to jot that down up here. So 54. So since it's -3, it's going to be -54. And the sequence would go on and on. All right, how about this? What is the rule for this sequence? 3, 7, 15, etc. So we want to find the rule like the nth term. If I want to find any term in this sequence, what would I do? So let's figure out what's going on here. So to get from 3 to 7, there's a couple different ways to do that. We could add 4, but if that's the rule, if adding 4 is the rule, then does it work here? 7 plus 4 isn't 15. So adding 4 is not the rule. What else could I do? What if I doubled 3 and I get 6? So if I double it, I get 6, I'd have to add 1. So let's try that. Let's try double and then plus 1. Does that work from 7 to 15? If I double 7, I get 14 plus 1 is 15. Yay! Okay, so it looks like that's the rule, doubling it and adding 1. So the nth term, so I'm going to write that I'm doubling, double, then add 1. So that would be the rule for this sequence. So the key is to figure out what works for every transition here. Like I said, this works adding 4 right here on the first one, but that doesn't work for the next one, if that makes sense. So you got to find a rule that works every time. Okay, so how about this next one? Write some terms of the sequence f of x equals 2x plus 3 with a domain. Remember, domain are the x values. We learned that in a previous lesson. A domain of natural numbers. So natural numbers are all the positive numbers, like 1, 2, 3, 4, and so on. Okay, so write some terms of this sequence if these are the numbers that we're going to be plugging in. All right, so let's start plugging in some of these numbers. If I plug in 1, 2 times 1 is 1. I'm sorry, 2 times 1 is 2, plus 3 is 5. How about if I plug in 2? 2 times 2 is 4, plus 3 is 7. How about if I plug in 3? 2 times 3 is 6, plus 3 is 9. So that is what the sequence would look like. Next, in the arithmetic sequence, arithmetic, this looks like arithmetic, it's called arithmetic. This means we're adding or subtracting a number, the same number every single time. So in the arithmetic sequence here, what is the common difference? What is happening between each number? So we know we're just adding or subtracting something. We're not multiplying or dividing by anything. So how do I get from -6 to 2 and from -2 to 2 and from 2 to 6 and 6 to 4? So it looks to me like we're adding 4 every time to get from one number to the next. So I would say add 4. If it just asks you what's the common difference, then I guess the answer would be 4. 4 is the common difference. Okay, recursive formulas. This is probably the trickiest part of this lesson, but it's not that bad if you follow the steps. So make sure you write down this example so you can use it on your checkpoint. Okay, so if they tell you A1, A sub 1, this is the first term in the sequence. That's why it has a 1. The first term is 3/4. Then they give you this weird looking formula. A sub n, A of n, equals A sub n minus 1 plus 1/2. So what does this even mean? This means any term in the sequence, A sub n, A of n, this could be anything. That's why it's an n right now. So any term in the sequence equals the term before it, n minus 1. So the term before the n plus 1/2. So basically the rule of this sequence was that you're adding a half every time. You're taking the previous term and you're adding a half. And what this thing does is it tells you, here's where we started. The sequence has to start somewhere. So this sequence starts at 3/4. So we need to find a sub 5, the fifth term in the sequence. Okay, so we know that it starts with 3/4. That's the first term. Okay, and we know that what this means is that we're just going to add 1/2 every time. You can plug this in if you want. Like, if I want to find the second term, a sub 2, then I would take the term before it, a sub 1, and add a half. So we know that a sub 1 was 3/4. So I have to do 3/4 plus a half. So I'm adding a half every time. So 3/4 plus 1/2. Well, 1/2, if I want to get a common denominator here, 3/4 plus 1/2. That's actually 3/4 plus 2/4. I just changed this to have a, sorry, you can't see that. Change that to have a common denominator. So this comes out as 5/4. And you can leave it 5/4. You can write it as a mixed number if you want, 1 and 1/4. That's up to you. So that's the second term. So now if I want to find the third term, I'm going to take the second term and add a half, because that's what this formula was telling us. We're adding a half every time. So I need to take 5/4 and add 2/4. So that comes out as 7/4. And I'm just going to keep doing that every time. I'm going to add 2 more fourths. So 9/4. And my fifth term would be 11/4. And that's what I was trying to find, the fifth term. So here, my fifth term would be 11/4. So that's how you use those recursive formulas. You can actually plug in numbers here if you want, or you can just look at this and kind of figure out, what is this actually telling me? Any term in the sequence equals the previous term plus a half. So that means take the previous term, add a half, add a half, add a half, add a half. Okay, so what about if we write it kind of in this function notation? So if f of 1 is 3, so the first one is 3, and f of n plus 1, so the next term, equals that term plus 6. So this is just a different way to write a recursive formula. They're saying the term after this one, you're going to add 6. So I'm taking the term f of n and I'm adding 6. And they want to know, what is f of 10. So f of 10, we know f of 1 was 3. Okay, so I'm going to start my formula with 3. So if you want to think of it like this, now I need to take the term before and add 6. So I'm going to take 3 and add 6 and get 9. Now I need to get all the way to 10 this time. So I'm going to have to add 6 a lot of times here. So 9 plus 6 is 15. 15 plus 6 is 21. 21 plus 6 is 27. Plus 6 is 33. Plus 6 is 39. Okay, that was number 7. Plus 6 is 45. Plus 6 is 51. And plus 6 again is 57. So there we go. So these are some examples of, like, you'll see on your checkpoint. If ever you have more questions or you want to see more examples, shoot me a text, email, IM, and say, could you give me more examples like this one? Take a picture of it and send it to me and say, could you give me a few more like this? Happy to help anytime. This is just a quick overview before you take your checkpoint. But if you need more individual help, reach out to me anytime.